Alrighty, in this video, we are going to be going over a bunch of the SID standards. So we are going to go through that. So let's talk about this first one. This is a box plot. It wants to know the median, lower, and upper quartiles. All right, so to figure this out, well, we have to know what in the world they're talking about for median, lower, and upper quartile ranges. What they're focusing on right here are these lines. Here where it falls, where this one falls, and where this last box falls. So we can see it's probably 12. This one's kind of hard to read, but if we look at C, we can see that's 12.7. It's probably that. And then right at 15. So the answer here is C. Alrighty, so select the box plot that represents the given test score. So what we're going to have to do is let's go ahead and figure this out. So what I do first is I try to find the median. So it looks like they were so nice and they already put them in order from least to greatest. So let's find our median. Oh, when we have a median that it's two of them, you add them up and divide by 2. Or we can just find the exact middle between 77 and 78, which is 77.5. So I am looking for one of them that has a median of 77.5. Well, when I look at C here, this is the median, and that is not over 77.5. So what I do in this strategy is I'm going to go ahead and eliminate C. Same thing with D. This is below even 75, so it's not 77.5. So we can go ahead and eliminate D here. So now I go through and make sure that my lowest number and my highest number is documented, which is 48 and 91. And they are in both, so I have to figure out what is missing here. So we're going to go ahead and try to figure out where this line is supposed to be at, which is the lower quartile. Okay, so what we do, I'm going to head and erase some stuff. Choose a different color. We are talking from here down. So now we have to find the middle of this. All right, so it's 64 and 68. Remember, we have to find the exact middle. Well, between 64 and 68, it is 66. So now we have to find one of those that is 66. So we have A, which it looks like it's over 65, and this one looks like it's higher at 65. It's a little bit difficult to see. So when I look at this though, I can pretty easily determine, well, it's not as easy as you think. This one looks like it's a little bit farther than just one past 65. So if I were to choose, I would choose your answer to be A. Okay, so which of the following dot plots is for this data? So what I'm going to go ahead and do is I am like a highlighter person. So for 8, I should have 1, 2, 3 8s in here. Okay, so that means there should be 3 dots above the number 8. So when I'm doing this, A has 3 dots, so it could be A. B only has 2 dots, so I know I can eliminate B. C has 3 dots and D only has 1, so I can go ahead and eliminate D. Okay, so now we're between these two, and the only difference between these two is 6 here has 3 dots, and this one has 4. So let's figure out which one it should be. So how many 6s do I have? I have 1, 2, 3, and 4. So if I have 4 6s, then I should have 4 dots above the number 6. So your answer should be A. All right, 20 of your classmates were asked to keep track of the number of hours of TV they watched for a week. After the week was up, the following data was collected. Which histogram best represents the data? Okay, so how they did this is they look like they did these in groups of 2. So, or sorry, this is 0 to 5, this is 5 to 7, which means it could include 6. So let's just start with this first group. Okay, so we have to sit and figure out between 5 and 7 how many numbers there are. So I'm going to go ahead and do some erasing, because this is not talking about just 5 and just 7. It's numbers between the two, which is the only number there is 6. And as I go through this information, I see that there's 1, 6. Okay, so if there's only one that's between 5 and 7, then A looks right because that only goes to the 1. B does not. And C goes to the 2. So that can't be right. All right, so now we are between A and D. So let's talk about numbers that are from 7 and ending at 9. So 7 and 8 point some 8.9999999 is what we're looking for. Let me get my highlighter. All right, so including 7, 7, 1, 7, 8, 7, pretty much the number 7 and 8 are what I'm looking for. Okay, 6, am I missing one? I feel like there should be one more. 1, 2, 3, 4, 5, 6. Oh, I guess we will include 9. So we are talking that in this group, 1, 2, 3, 4, 5, 6 different 7. Sorry, 7 different people were between the 7 and reaching the end of 9 minutes. So our sign, oh, hours. Oh, wow, hours. Okay, so we're probably looking at D here. And even if you weren't even sure about the number 9 to add it into the data, we can pretty much eliminate that it was more than 2. So we are going to just go ahead and say the answer is D. All right. Noah conducted a survey on sports participation. He created the following 2 dot plots to represent the number of students participating by age in soccer and basketball. Which statement about the given data sets is correct? A. The data for soccer players is skewed right. When we have this, that means that most of the dots are going to be over here. Kind of like this. Like this one is skewed right. So I don't think it's A, because for soccer players, it's not. The data for soccer players have less spread than the data for basketball players. The data for, okay. Right, so the data for soccer less spread than data for basketball players. So we're going to go back to, so when it says less spread, that means is it more spread out evenly? To be honest with you, I think the soccer players are pretty evenly spread out in their age, whereas basketball players tend to be on the older side. So I don't think B is correct. All right, the data for basketball players has the same median as the data for soccer players. So in order to find out the median, we could lay out all the numbers and cross them out and to come to the middle. I'm going to do it via dot, to be honest with you. So I'm going to cross out dots. All right, so this one is between 8 and 9, so it's 8.5. So let's figure out this one. All right, and this one will have a median of 10. So that's not true. The data for they don't have the same median. All right, so it's not C. So for D, it says the data for basketball players has a greater mean. Now you can, to find the mean, remember you add them all up and divide by how many there are, and you're welcome to do that. Or you can just use the elimination process to see. All right, use the table to answer the question. Which conclusion about t-shirt prices at Cool Clothes and Ben Clothes is best supported by the data? So when you see something like this, you're not going to probably be able to get a straight provable answer. But using this data, we're going to try to make our best guess. Some high-priced t-shirts at Cool Clothes make the mean higher than the median. So their mean is much higher than their median. So when we talk about this, the mean could, like some higher price shirts could pull the mean higher. So they could have maybe one or two shirts that are very high priced to increase the mean, but it wouldn't necessarily move the median too much. So this could be true. The fact that the mean and the median are very similar at Ben's shirts shows that all of the shirts' costs are under $15. Well, let's look at this. If the median is $14.99, that means that there's most likely shirts over $15 because we're talking about the median. This isn't the highest it goes. So we definitely know that it's not B. Comparing the mean prices shows that most shirts are cheaper at Ben's than at Cool Clothes. Well, let's look at the mean. Most shirts are cheaper at Ben's than at Cool Clothes. Well, that's not wrong. So it does see that the mean is lower at Ben's. So comparing the mean prices at most shirts, but this median for Cool Clothes is smaller. So there are other prices in here, so they could pull down the median. Comparing the interquartile range shows that t-shirts at Cool Clothes are about twice as expensive. Okay, so just because that this one at Cool Clothes is a double does not mean that all of them are double. This is your interquartile range. So that does not prove. So we're kind of between A and C. So when I look at this, the mean prices that show most shirts are cheaper at Ben's. This kind of makes me look that not most shirts are cheaper at Ben's because their median, they have a smaller median. So that means the middle of their numbers is even smaller. So I don't think it's C. I'm going to go with A. Alrighty. So let's go ahead and do this one. Just so you know, if I don't finish this one within this video, I'll finish it in part 2. A random sample of 200 teenagers participated in a taste test. Each teenager sampled 4 choices of fruit drink, A, B, C, and D, and they were asked to pick a favorite. The table shows the result of this taste test. Based on the information, which ones are true, select all that apply. So when it says something like this and you are taking your test, select all that apply, that means there's more than one. Okay, and they'll have boxes here instead of like dots to select. Okay, so let's go ahead and just go through one by one. 40% of the participations were girls. So in order to read this chart, girls, there were 80, and in total, there were 200. So we just have to figure, we're going to go ahead and I'm going to break this down by, okay, sorry. So if you want a calculator, you can just do 80 divided by 200 equals 0.4. So 4, that is 40%. So this is a true statement. 40% of the participants were girls. Okay, 70% of the participants preferred A. So let's just look at the A column, and that total was 70. And the total amount of people that were questioned were 200. So if we put this in our calculator, let's clear all. We have, 70 divided by 200 is 0.35. That's 35%. So that one's not true. So we're not going to check it off. Okay. 20 out of 120 of the boys preferred D. So we're just looking at the boy column. 20 of them did prefer D, and in total there were 120 boys that were a part of the taste test. That is true. So that one's going to work. Let me go ahead and erase some of this on the board. All right, 10 out of 35 of the participants who preferred B were girls. Okay, so in total the ones who preferred soda B, there were 35 in total. 10 of them were girls, so that one's true. So you want to talk about more than one answer? The proportion of boys